So in this video, we'll start with finding average velocity using similar techniques that we've learned so far with using limits and such. In this case, for an average velocity, we're not getting close to zero. That's going to be called instantaneous velocity, meaning at a particular point along a trajectory. So in this case, just the average velocity is much easier to find. We've been given some information here, such as how to find that average velocity for the function of s at t, which is equal to 1 plus 3 times t minus 2 times t squared. And it says on. This is important. It's not at 1 dash 3. It's on 1, 3. And what that actually means is that we could say that for, in this case, we would say that for t sub 0, and t sub 0 plus h, what they've given us is along that time. So we would say that the x-axis is actually time. So it's speed of an object over time. So time tells us distance. So how long it took you to get from point A to point B. And along that axis, we would say that this is on 1 and 3. So along a trajectory, 4 points, points of time 1 unit, and points of time 3 units at the end. So along that trajectory. So we can replace t sub 0 with 1, and we can replace t sub 0 plus h with 3. And that's because we're using average velocity, and those two times are given. So that's important to understand the distinction between on 1, 3, and if I said at, so if I said at 1, 3, there'd be parentheses here, and that would tell us that this is actually an x and a y. In this particular case, this is x and this is x. So these are 2 points along time. So let's keep that in mind. Now, the next thing that we can do is, just as we have been doing, the very first process is going to be to find what we've been calling anyway, f at t sub 0. In this case, we're actually dealing with the function speed for every input of time. So s is going to be equal to the speed of an object in some unit. It could be feet per second, let's say, feet per second. And then, of course, t is going to be distinguished by time it took. So what we would actually do is start off with s, and we would say s at t sub 0 is equal to, and what we know about t sub 0, we've already been given, is that it is equal to 1. So we know that t sub 0 equals 1. Therefore, we can then say that this is s at 1 is equal to, and then we can place 1 into our function and get our speed. So for a time of 1 foot per second, we're going to have s. So we'll say 1 plus 3 multiplied by 1 minus 2 multiplied by r1 squared. So we put that in here and then solve that down, and we end up with 3 times 1 is 3 plus 1 is 4, minus 1 squared is 1, 2 times 1 is 2, so 4 minus 2 gives us a value of 2. Next, we have our input for at 3, so we have s of t sub 0 plus that little bit of h is equal to, and we've been given that value of time as well for 3. So we can just say that it is s at 3, which is equal to 1 plus 3 multiplied by 3 minus 2 times 3 squared. So we're going to put that in here, and then we'll solve it down. So we're going to end up with 3 times 3 is 9 plus 1 is 10. And 3 squared is 9 times 2 is 18. So it's 10 minus 18, which is going to give us which is going to give us -8. Next, we want to find h, because we do see that we're using this same formula and the difference quotient. So for h, we're going to determine that h is going to be equal to our endpoint, 3, minus our starting point, which is 1. And we find that h is actually equal to 2 as well. So we can say that h is 2. Now that we have that, we can actually plug all of our values in, and we can find that average velocity for this object. So we can use, bring this down a little bit, and we said that our first value for s at t sub 0, when t sub 0 equals 1, we ended up with 2. We said that s at t sub 0 plus h is equal to 3, and when we plugged that in, we ended up with -8. We said that our h is equal to 2, and when we set up that formula, we're going to say that our velocity average is going to be equal to s of, and we'll take our largest point. We'll take this t sub 0 plus h, and we plug that in. That's 3. I'm sorry, that is 3 for the function of s at 3 minus s at 1, all over, and h we said is 2. Since we've already completed this function, this declares the function, meaning that we're going to input 3. We did that, and we got -8. And then at s t sub 0, which is 1, we plugged that into our function, and we got 2. And we found that h is going to be 2 as well. So that ends up being -10 over 2, which is going to give us -5. So we have a trajectory between those 2 points, where we're calling this point along our t-axis. Remember, we replaced the x-axis as t, so that was t sub 0. And at this point, we're saying that this is t sub 0 plus h. And because it's negative, that means that it's traveling, we could say, we're not told that it's feet per second, but we could say that it's traveling at a velocity of -5 whatever feet per second. And now that we have that, of course, we could then in turn create an equation of that line, of that trajectory as well. So in this case, we just found the velocity average. In the next video, we're actually going to look at how we use limits and derive an instantaneous velocity at any given point. And of course, the two ways that you can do that is to have a point given in the beginning, solve that down for that particular point, or as we learned, we can also create a slope, an instantaneous slope equation, so that we can utilize it for any point along that trajectory. I hope that helps, clears things up. Thanks for watching.